Exponents have traditionally been a very important part of your exam. And while they can be intimidating, there are just 6 rules that you have to be fluent with to do well with exponents. The first rule is that when you multiply common bases, you add your exponents. So in this case, my bases are just 2 3's. Since they're the same, I can add my exponents, so I can rewrite the problem as 3 to the 2 plus 2, or 3 to the 4. One of the rules of multiplication is that it doesn't matter the order you multiply two numbers. So I could rewrite this problem as 2 times 5 times n to the 4th times n to the 4th. My 2 and my 5, well, I just follow the normal rules of multiplication, and that becomes 10. On my n to the 4th times n to the 4th, now I have common bases, so I'm going to add my exponents. So my final answer is 10 times n to the 8th. The second rule you have to memorize is that when you divide common bases, you subtract exponents. So I could rewrite this problem as 2 to the 4 minus 2, or just 2 squared. If you want to see why that actually works, you could rewrite the problem as 2 to the 4th, which is the same thing as 2 times 2 times 2 times 2, 4 times, divided by 2 squared, which is 2 times 2. If we draw it out that way and we just follow our rules of fractions, the 2 on the bottom cancels out the 2 on the top, and we're left with 2 2's on the top, which is 2 squared. Your next rule has to do with negative exponents. Negative exponents simply mean you move the number or the variable from the top to the bottom of a fraction. So in this case, if I have 4xy all to the negative 1, I'm going to take the 4xy and put that on the bottom of a fraction. So my new equation is 1 over 4xy. If by chance the original equation had been 1 over 4xy parentheses to the negative 1, then I would just do the opposite. I would take what's on the bottom and move it up to the top, making that equation 4xy. In our last problem, we had a 4xy with parentheses around it, all to the negative 1. Because of the parentheses, the negative 1 was being applied to the 4 and the x and the y. In this case, I have a negative 3, but since there are no parentheses, the negative 3 is only being applied to the n. So when I move my n from the top to the bottom, I leave the 2 alone. So I could rewrite this problem as 4 times n to the 4th times 2 all over n cubed. Now, because I'm dividing exponents, I'm going to subtract the bottom from the top, leaving me an n to the 1 on top. My 4 and my 2, I just multiply those as regular whole numbers. So I get 4 times 2, which is 8, or my final answer is 8 times n to the 1, or I could just write that as 8 to the n. When you have multiplication inside parentheses, and then on the outside of the parentheses you have an exponent, that exponent gets multiplied across the other exponents inside the parentheses. So I could rewrite this problem as 2 to the negative 4 times x. I'm going to multiply my exponents, so I get 2 times negative 4, or negative 8. Then, because my exponents are negative, I'm going to put my numbers in my variable at the bottom of a fraction. So my final answer is 1 over 2 to the 4th times x to the 8th. The rule of multiplying and distributing your exponent across a parentheses does not apply when you have an addition or subtraction sign inside the parentheses. If this problem had been written as x times y parentheses squared, then you could rewrite that as x squared times y squared. But because we have the addition symbol, we actually have to rewrite this problem as parentheses x plus y times parentheses x plus y. And then it becomes a standard quadratic equation, and you have to use FOIL, where you multiply first, outer, inner, last. And your final answer becomes x squared plus 2xy plus y squared. The next rule is that anything raised to a 0 exponent equals 1. So in this case, we don't care at all what the a and the b are because it's raised to a 0. So the answer is 1. And your last rule is that if you ever have two numbers set equal to each other and their bases are the same, if the bases are the same, then that means their exponents must also be the same. So that means I could rewrite this equation as 2 to the x plus 1. That must be equal to 4x minus 3. And then I just solve like a normal linear equation. Subtract 2x from both sides, add 3 to both sides, and I get 4 is equal to 2x, or x is equal to 2. So here's a problem that's about as tough as you're going to see on your exam. Most likely you won't see anything nearly this complicated, but still a great exercise to apply our rules. The great thing about the rules of exponents is it doesn't matter the order you apply them. The first thing I'm going to do is distribute my negative 4 by multiplication across everything in the parentheses. So I get 2 to the negative 4 times p to the negative 4 times m to the positive 4 times q to the 0. And anything to the 0 power, that's just going to become 1. Next, I'm going to try and add or subtract any exponents that I can. I see on the top that I have a 2 to the negative 4 and a 2. So that's going to become 2 to the 3 because I added a negative 3 and a 1. Next, I'm going to add my p to the negative 4 and my p cubed, and I'm left with p to the negative 1 on top. Combine my m's, and I get m to the negative 2. And then on the bottom, I have a 2pq squared. Now, since I'm dividing, I'm going to subtract my exponents, and I'm left with a 2 squared on top. When I subtract a negative 1 and then minus a 1 on the bottom, I'm actually left with a p to the negative 2 on top. Nothing changes my m to the negative 2, and nothing changes my q squared on the bottom. My last step is to take my negative exponents and move them to the bottom of my fraction. So in my final fraction, I have a 2 squared that stays on the top. Then I'm going to move my p squared down, and I'm also going to move my m squared down, and I have a q squared that was on the bottom the whole time. And that's it. 2 squared over p squared times m squared times q squared.